You see, we have different types of packets. Different types of packets. You might have seen, when you are working in an organization, you will have different type of announcements. Some are not, okay, let's take school. Different type of announcements. Some announcements are common to the entire school. Some are only for the higher secondary, some are for the primary, some are for the kindergarten, and some are very specific to one of the class. So in an assembly, in a school assembly, we get announcements, different types of announcements to run the school successfully. Likewise, some announcements are for teachers, announcements are for students, some announcement for the management people. A lot of things comes as an announcement type in a school assembly or a college assembly. In OSPF also we have different types of announcements, packets. One is hello packet. The job of this packet is to make sure the neighbors know that I'm alive. That's all. The purpose of this packet is to tell the neighbor that I'm alive. Not only that, to make new neighbors know about me. That's the purpose of hello packet. And then the DBD, database description, is another type of packet. Database description, what does it mean? See, database, every router has got database, which we call as LSDB, link state database, LSDB. Why they are not calling LSDB? Why they are calling DBD? LSDB is not advertised. DBD is advertised. DBD, database, LSDB, link state database. This is also database, that is also database. Is it different name but same thing? No. LSDB is what you will see when you type show IP OSPF database. But DBD is different. LSDB is not the one which is sent between the neighbors. DBD is what going to be sent. Now what is the difference? Both are database. What is the difference? LSDB is the detailed database. DBD is a summarized database. Summarized will be one handful. Detailed will be like one mountain. Instead of sending the LSDB, which is detailed one, the mountain size update, we send a handful of message which conveys the same mountain size message. When I was in school days, I have seen teachers how they correct the essay writing. Essay writing, write about the country India. That's the title of the essay. We say introduction. Every country has got something so unique. Likewise, India has also got something very unique, which I am going to describe in the below paragraph. That's the introduction to the essay. And then I write pages after pages. At last I write one summary. So, India is also one of the beautiful country with a lot of natural resources and natural security boundaries, like Himalaya protects from the cold and wind, and the ocean surrounded by India, which protects from the neighboring country evil forces. Not every neighboring country, all neighboring countries are friendly, but there are some forces here and there, evil forces attacking, which is not possible because of the three-side ocean, Indian Ocean, the Pacific Ocean, and the Arabian Sea. So India is the highly secured, beautiful country. Boom. Summary is over. So teachers, they don't read all the pages. They go to summary, what he has written in summary. That 4 or 5 line helps them to understand that 4 or 5 pages. They get all the entire 4 or 5 pages of information just by reading this 4 or 5 lines. Likewise, DBD is the summary of LSDB. DBD is also sent between routers. Along with hello packets, DBD is also another packet type that are sent between routers. Whenever a change happens, the sequence number gets incremented and immediately update will be sent as DBD. DBD goes, but again, the teacher is very curious. Hey, come here. You have written that India has got a lot of diversity. What does that mean? So teacher itself has got some doubt. He has got some doubt. In the summary I have written, India is united in the midst of a lot of diversity. What? What is the diversity? When you say language, color, different status level, which is commonly seen in every country. Okay, teacher is very happy now. Which we called as LSR and LSU. Teacher was asking the question, what is this diversity? That is LSR, link state request. So even though the summary is there, which describes the entire essay, but still the receiver has got some queries to clarify. The receiving router have got some queries to clarify because the DBD is not the detailed one, no? It's a summary. So to clarify, link state request is sent. As a response, link state update will be given. So in this, hello packets are going to use multicast address. DBD is also going to use multicast address. LSR and LSU will use unicast address, but sometimes also multicast address. It depends on the query type and the response type. So at last we come acknowledgement. This acknowledgement will be sent for every packet except the hello packets. Like this, we got hello, DBD, LSR, link state request, LSU, link state update, and acknowledgement, link state acknowledgement, ACK. 5 types of packets. This is the number, this is the order. 3 means it is DBD only. 5 means it is acknowledgement only. 1 means hello packet. 2 means DBD, not 3. See, this number is not just serial number. This is the number that is maintained while sending the packet. The Wireshark, I can show you these things very clearly. So you can easily filter out only the LSR. If you want in Wireshark to see only the LSR routers, I can easily filter. How? I'll say show me only the OSPF packet type 3. It will show all the LSR. It will show whether the LSR is sent as a unicast or multicast. I told you, sometimes it will also use multicast. So, to see those things, you need to know these numbers. You can also see these by typing debug IP OSPF packet. Debug IP OSPF packet will show you all the packets, OSPF packets with the packet type number, like this. You see, debug will show you this. This is normal IP packet where you have protocol field. In the protocol field you will have this OSPF or protocol number 89. When the protocol 89 is on, these fields will be automatically created and you will see version 2. What is version 2? OSPF version 2 is the version which was designed focusing on IPv4, but now IPv6 is also supported. But there is another version called version 3 which is supported both IPv4 and IPv6, but it is designed keeping IPv6 in mind. So we got two versions, version 3 and version 2. The type which we just saw, packet length, depending on the type, the length will vary. The router ID of the router, every router will have a unique ID in OSPF called router ID. Area ID to which the router belongs to. Checksum will be dynamically generated. Authentication type, OSPF supports 0 authentication, 1 authentication, 2 authentication. There are totally 3 authentication, type 0, type 1 and type 2. That will come here, the clear text, null and the MD5. And then the authentication password, the hash values, and then the payload, the data it carries, the OSPF packet carries. More detail we will see when we capture a packet using Wireshark. Even in debug you will not see that clear output. Wireshark can give you that clear output. That's how the CCIE study should go. Now, the hello packets have got these things inside the packet. Hello packets will have a router ID. Hello and dead interval means the timing. We learned that the dead interval is 40 seconds. The hello interval is 10 seconds. These timer informations are shared in the hello packet. Neighbor list, area ID, router priority, the designated router address, the backup designated router address, authentication password if enabled, stub if enabled. Now, among all this, the router ID should be unique. Two routers cannot have same router ID. The hello time and dead time must be common, matching with the neighbor. Router ID should not match with the neighbor, but the hello and dead interval should match in order to form neighbor. In the previous chapter we saw, when the hello packets are sent, they will compare the hello packet and look for certain parameters to match. So these are the parameters that are supposed to match: hello interval, dead interval, area ID, authentication password if authentication is enabled, stub if stub is enabled. We have 4 different types of stub. Depending on that, the stub flag will be varying. That stub flag should match. Only then the neighbor will come up. If one router is configured as stub, the other router is not, they don't form neighbor. Now, any questions so far? Silent class.
So this stub error flag, is it sent by default in the hello packet?
No, it will be 0 by default. Only when you enable stub it will be there on. 0 or 1 will be there. 1 means on. Then the neighbor also need to have 1. Yeah, right. Any other question on packet types? We have finished packet types. And now next is establishing bidirectional communication. How OSPF forms neighbor by doing bidirectional communication. What are the steps? There are 7 steps or 7 states. First one, they talk each other to understand their levels. Here you see A is talking to B first time. See the arrow mark there. Hello. Hello is going from which address? 172.16.5.1. That's the router ID. And this also says, I see no one, meaning router A says, I don't have any neighbor. I don't have any neighbor. Yeah. And that is sent as what? A multicast packet. 224.0.0.5. A multicast address. I see no neighbor. I was telling in the previous slide, the neighbor list will be sent, you see, the neighbor 3. That's what. This is the first time, you just configured router A. So definitely there won't be any neighbor for router A. And now router B is listening to this, because router B is also just configured with OSPF. All the routers that are configured with OSPF will start listening to this multicast address 224.0.0.5. So B learned A. B has learned A. Which means B has got a neighbor called 172.16.5.1. This turns on init state on router B. Earlier there was no neighbor, down state. But now B goes to a new state of relationship in OSPF called init state. Initialization state, a beginning state of neighborship, because router B knows A as a neighbor, but A do not know about B. That's why it is still in initialization state, init state. Now B is sending hello packets with A's address saying, I have a neighbor 172.16.5.1. And then it is sending as a unicast. You see, unicast to A. It is sending to A saying, I have this neighbor. And A says, hey, this is me. You know me already? Okay. Now I know you and you already know me. Then we both are in a two-way state. Two-way state. Next. Discovering the network routes. So this is where they are going to exchange the DBD. Whatever router A knows, it will give to B, and whatever B knows, it is going to give to A only after this two-way state. After this two-way state, immediately it won't give, it will decide who will initiate it. That is what called as exchange start state, start state, exchange start. Not exchanging, exchange to start. To start the exchange, this both, they need to first come to a conclusion who will start the exchange first. Both should not send the same time. One should send, other should receive, the other should send, the other one should receive. That is the procedure. So, router 1 says, router A says, I'll start the exchange between, and this is my router ID. Router B says, no, very bad habit you have. Wait, see, you are only 172.16.5.1, but who am I? 5.3. Tells I am 5.3. I'm not that small boy. I'm 5.3. I should send it. I have the higher router ID. This conversation is what called as start state. Start state. So before they start the exchange, they decide who will start the exchange. Router B is eligible now. Next, after saying that, router B is saying, okay, let me start my exchange. It is sending my DBD. It is sending, see, summary of LSDB is what called as DBD. And then router A is also sending the summary of its own LSDB. Sharing this DBD is what called as exchange state. Next is, after sharing the DBD, they both send the thanks message. Okay, I got your DVD. Thank you. They both send the acknowledgement, which is called as, again, exchange only. In the exchange only it happens. Now, after that, they got some queries. So link state request is going, hey, I want some clarity on this network. Do you know anything more about this network? Can you explain me more? And this B says, okay, here is the entire, here is the information, the entries about that network. It's in response. It's in response to the request. So we call this LSU, link state update. After a point of time, they don't have anything to query. So they finish their loading state. They load Paka. They are fully synchronized on either side. And then they meet full state. They reach full state. Yes. So these are the stages: down state, init state, start state, exchange state, loading state, and full state. See, here they have written DR. I'll talk about this later in another class. You will not have this DR when we have serial link. This is because of Ethernet link you have DR. But I'm going to use a serial link which is not explained in this presentation and demonstrate now to you. So there will be a master. The one with the highest IP address will be considered as master. The lowest will say we are slaves. And the master will do the exchange of DBD followed by slave. And this master-slave relationship will be only till they say acknowledgement. After that, there is no more master, no more slave. Master-slave relationship will start here. It will start from here. Okay, to be more clear, it will start from start state, not from start state. In the start state only, they will say, "I am master, you are a slave," all those stuff. They fight. Not fight, they are very decent. Okay, this is going to say, "Yeah, you are right, we are slaves. We are very happy to be slave under you. You are a very good master." And this will proudly say, "I am the master." And the master will give from the treasure all the wealth that he has got. That's why he is a good master, and this man agrees to be a slave. And then the slave will also send the DVD. And then they share the acknowledgement. After that, there is no more slave, no more master. They are equal. They are going to ask queries and responses. Full state. Let's see this in action. So we got two of our routers ready. We need to just put the IP address configuration on the routers. I'll use Notepad for this. Notepad will save our time, no? Enable config T interface loopback 0 IP address 111.111.111.111.255. You see, I'm going to put both the routers in OSPF area 1. Focus here. You might have done OSPF earlier in a CCNA by typing router OSPF and then the network and then the wildcard mask and the area ID. You can straight away say like this on the interface IP OSPF 1 area 0. This reduces a lot of your work. You don't need to go back to the global configuration mode, typing all those wildcard masks and area IDs. Not necessary. You can say on this interface, I want to run OSPF, and the process ID of OSPF is 1, and the area that in this interface now must be member is area 0. You can say all these things in one shot. And what this OSPF will do, whatever that you have configured here, that network, it will start processing it and it will start preparing a DBD for it and so on. Next, interface S2/0 here, S2/1 here. Tender 12.0.1 255.255.0.0 IP OSPF 1 area 0. Finish by saying end. You will be in the privilege mode. Write to memory to save it. For some reason, I'm going to keep this shut down because I want to show you the debugs. I'm keeping it as down. Okay. Next is router 2. Here this is going to be 2 and this is going to be 22. OSPF will automatically pick. The OSPF will automatically pick the loopback interface, the highest IP address on the loopback interface.
Router 2, the interface is different.
Okay, I understand. Thank you. Router OSPF will automatically pick the loopback interface, the highest IP address on the loopback interface as a router ID. So Joseph, please tell me what will be the router ID of router 2. Oh, louder please. Louder please.
10.12.0.1.
What I said is OSPF will pick the highest IP address on the loopback interface as the router ID.
Yes.
What will be
0.2. Yeah.
Listen carefully again. OSPF routers will pick dynamically the highest IP address on the loopback interface as the router ID. So what will be the router ID of router 2?
22.22.22.
22.22.22.22. This is what going to be picked as the router ID. It won't pick this one. Even if this is 100, 100 is bigger than 22. It will not pick this 100. Why? It will only prefer loopback interface first. If there is no loopback, only then it will come to physical interface. We have not discussed this, I know, but we will discuss it later. I asked this question because we should know this now. Okay, I copied and I will paste it on router 2. Alright. So now I'm expecting neighbor, but it won't come because it is down. The reason I keep it down is I want to use a Wireshark and show you a few things. Now this is blank because we have not even said no shutdown. That's why it is blank. The Wireshark is blank. Now let us bring the interfaces up. Before that, I also want to enable debug command. Debug IP OSPF adjacency. Debug IP OSPF adjacency. Done. Now let us go and say no shutdown. Interface serial 2/1 no shut. Also on router 1. Yeah. Done. Now you're going to see here packets coming.
So I think both the interface ID so the
What did you say?
interface ID enabled in router 2 we need to 2/1 interface we have to enable.
கொஞ்சம் நல்லா தெளிவா சொல்லுங்க, புரியல.
சார் கேக்குதுங்களா நான் பேசுறது?
பேசுது ஆனா ஒரு மாதிரி கூட
இருங்க அந்த ஃபேன் இப்போ
இல்ல கொஞ்சம் மைக் தூரம் வச்சு பேசுனீங்கன்னா போதும்.
ஹலோ சார் கேக்குதுங்களா?
Now what did you say is some interface mismatch, right?
Yes, sir.
But that is not no, that's not the problem.
We need to enable 2/1.
No, that is what we did, you see. In router 2, it is 2/1, no shutdown. That is right only. Okay. So, this Wireshark couldn't capture this, so don't worry about it. That's not needed now. Let us find here itself. Look at this. This says, we are slaves. You know who is saying we are slaves? Router 2 is saying we are slave. Can someone say why? What happened? Why are you so silent?
Slave R1 is the master.
Why R1 is the master? Why R2 is a slave? R1 says we are master. R1 says we are not slave. Come again?
Biggest
Yes. Router 1's loopback address is 11111.
Okay.
Whereas router 2's loopback is only 22. So router 1 says we are not slave, we are master. And router 2 says, after two-way state here, it says, yes, you are right, we are slaves. So what happened is the master will immediately send the DBD. Okay, it immediately sends the DBD, and then slave will send the DBD, and then they send the link state request to a unicast address, and then link state update comes. Link state update comes, and then acknowledgement will be sent. That is what called as loading to full state. It will go to loading state and it will reach full state. See, loading to full is here. So it is the master and slave, not DR BDR. When you have serial, there is no DR BDR. That's what I want you to know in today's class. So what we have learned today is about different packet types. Don't forget 5 different packet types: hello packet, DBD, LSR, LSC, acknowledgement, and all these packets.
Can you open the debug, sir, once again? I just want to check.
And all these things will be captured in Wireshark as well as in the debug, like this. Debug, the command that I used is debug IP OSPF ADJ. ADJ means adjacency. Right? Fine.
Yeah.
Do this and see once in your own place. Okay? Or we'll